Yeah, I mean, today we will talk about the Cobrapin system. Um, as you probably all know, or most of you know, Cobra did like a Kickstarter where he built uh, Open Pinball project based board. Yeah, basically a carrier board, and you could back it. I did, for example, and yeah, had it shipped to Germany, and finally it arrived. And I got like a nice package, and I mean, it's not quite an unboxing because I already connected stuff, but I will show you what I got from Thomas, and yeah, we will play a little bit with the hardware. So that's like the Cobrapin sticker I got. That's awesome. And yeah, let's just jump into it, I would say. So we got this agenda. It's quite boring. I will give you an overview about the hardware, and then we will have a look at the hardware. So it's as simple as that. And yeah, so the Cobrapin hardware. So I stole this picture from Thomas actually, but it's very, very good. So in the middle you will see like the Cobrapin board, and the Cobrapin board is basically a carrier board. It carries those two CPUs here. Those are those STM32 based OPP boards with the newest and latest and greatest Open Pinball project firmware. They both connect via USB-C to a host computer, and probably like that's something which I actually had to get. So I didn't have like USB-C connectors, at least not sufficiently, because I also need one for my mobile phone and so on. And so I had to get some USB-C connectors. So if you get the Cobrapin, make sure to get some USB-C connectors as well. So what can it do? First, it contains, so if you look like the traditional package of like pinball control systems, usually it starts with like the power supply. So the power supply is not included. You still need to get the power supply, and you typically want like one 5-volt power supply and one high voltage power supply, which is nice because like with fast or the multimorphic system, you also need 12 volts, and here you only need 2 voltages. That's an improvement in my opinion. So that like simplifies it a lot. It gives you more options for the 5-volt supply, and yeah, you can run like only 2 supplies instead of 3. Like a lot of people run 3 supplies. So that's really nice. And then it contains fuses here. So I looked this up, and Cobra told me how it actually works, because I got it wrong the last time when we talked about it. So there are like 3 fuses here, and those are for the banks A, B, and C for coils. So those are like fused separately. Power goes out here, and then you run high voltage from here up to your coils, and that goes back into the bank here, and that then connects to ground. Yeah, like here you should add like a diode to this coil in this direction, but if not, there's also like a diode on this board, so it won't instantly fry your fat. So that's good. That's well done, I would say. So you can have like 24 coils, if I can count it correctly, and those connect to those 2 CPUs, and we will come to this in a minute. Next, you have like another fuse here that's 5 volts, and 5 volts is used for serial LEDs. So there's one fuse for that. That's also great. I guess like some people do not fuse those at all, but it's a great idea in my opinion. And there are also like large capacitors which will basically flatten your power. That's really great. So basically this already includes the power filter or power entry board, how it's called for other manufacturers. And if you think about like the price, this is like I think 150 euros or dollars, I don't know. Yeah, dollars, I guess dollars. And like power filter boards at other manufacturers are already like 50 bucks. So that's a bargain already, right? Then it has like 2 chains of serial LEDs, which can be long if you want. I think quite very long. Like there's the limit, but you probably won't use it up, right? In my opinion, like 2 is not like, it's not very much. So I personally prefer to have like more chains, but it's probably enough for most machines. Okay, it's 256 pixels per chain, so that's I guess that's enough for most machines. So you get 512 LEDs. That's that's a lot. But you have to be a little bit careful with power. And for that reason, there's like an additional connector here where you can get 5 volts and ground from the board as well. So it's also fused. And that totally makes sense for long chains. You should definitely connect the chain at the end, and depending on your wiring, also in the middle. So otherwise your voltage will drop too much and then it will become unreliable at some point. So but that's there. So you can totally like go with it. It's a little bit like on the on the side with a little bit like with fewer chains, but definitely something which you can work with in a machine. Then there's like some addition here, which is included in some power filter boards. That's like a relay output. And the idea of that is that you can basically add a relay, which then sits between the power supply and this board. And that's basically for your door switch or something. So, or if you want to turn down high voltage in software during service mode, for example, and then you can do that. And that's also like, it's a good idea, and it's a great option. So you do not have to buy the relay. It costs some money, but you can if you want it. It might also be needed in some countries, but probably not in too many, because like Stern kind of, removed that high voltage disables when you open the door. So I guess it can't be can't be too bad. So what's the maximum number of coil switches that can be attached? So that's like 24 coils here. Those are the coils here. If you use this relay output, then you lose 1 coil as well. So then it's 23. Switches is, that's basically the next thing. It has 24 direct switches here, and a switch matrix with 64 switches. So let me calculate. 64 plus 24, it's 88. Yeah, right, 88. It's 22 direct switches. Okay, because like you lose some for the serial LED, I guess. Okay, then it's 64 plus 22. That's 86. So it's 86 switches, and that's quite a lot. And it's a switch matrix which you have to like, or which you may like or dislike, right? So some people like switch matrices because it's a little bit less wiring, but on the other hand, it's also like a little bit more complexity in your wiring. So Stern doesn't do it anymore because they run node boards and that's their strategy. But it's still a valid option, right? So it's definitely possible. Alternatively, you can also have like 16 switches here. So then it's then it will be 8. It's 40 switches then, 40 direct switches, or minus 16 and minus 2. So it's then 38 switches. 38 switches. So that's probably enough for most machines. It's a little bit low probably. So I guess like most machines run around like 48 switches or something. That would be my rough guess what the typical machine uses. So like Stern LEs, they go near 64 switches, and like the premium is around 48. So that's the range there. So it's definitely enough for a normal machine, I would say. But without a switch matrix, it might be tricky. So then you might need like one additional board somewhere. And that's definitely possible. We'll come to that in a minute. Because yeah, and then you connect like the stuff to a USB, and that's it. So I told you before that this is basically a carrier board for Open Pinball project. Yeah, and that's right. And the point is like that Open Pinball project has like multiple chains, and I put this on the next slide. So if we basically like separate this board, technically it's like this is actually two CPUs, and therefore like two boards from an OPP perspective. So from an Open Pinball project perspective, this is two boards. So one is like the first CPU that's connected to those coils and those switches here. And additionally, it runs like one of the serial LED chains. That's one of the CPUs. That has like one consequence. This Open Pinball project that works similar to Stern noteboards or to fast, to fast or Stern noteboards. Multimorphic works a little bit different, but for like Stern Spike and fast, there's basically the condition that hardware rules for example flippers, have the switch and the coil on the same node, and that's true here as well. So if you configure, if you wire up like your flippers or your flipper coils, make sure that your flipper buttons are on those switches if your coils are on those banks. That's important. If you put the flipper coils on this bank, then those switches won't work. Then MPF will bail on you and yell an error message at you. And similarly, you can use like the second CPU, that's this one. And this CPU is then connected to the remaining coils and to the switch matrix and one of the banks of the direct switches. Additionally, it also runs like this relay output, and it runs like one of the serial LED chains. But theoretically and also practically, you can have like more CPUs. So you can have like additional CPU, and that will basically give you additional 32 outputs or inputs, whatever you want. So that's the basic rule in Open Pinball project. Every CPU is roughly 32 of something, whatever you want. So you can have like one serial LED, that's one I/O port, then a few inputs, a few outputs. And you can add those like basically arbitrarily. So you could also like build a carrier board with 3 CPUs if you need more of anything. Or you could, for example, put one CPU in the cabinet and put this below the playfield. That's also an option. Or like one CPU in the back box as well. Because like those CPUs are not very expensive. They are quite cheap. I don't know how much those are, but I'm pretty sure below $10. I guess the first one was like $4. So even if you mess up really bad, you burn up the CPU, yeah, just get a few spare ones. They are really, really cheap. And one of the things on this board actually is that there's very few input protection here on the direct switches. So if you put any voltage here, it's very, very likely that you fry the CPU. And yeah, I mean, theoretically, you could add like chips here on the board, and then you would fry those chips instead. But on this board, it's actually that the CPU is so inexpensive that it wouldn't make sense to fry other chips because they would just cost the same as a CPU. So that's the reason here. So you can fry the CPU, but then also you can also just replace the CPU for a few bucks. That's the good thing about this board. And that's also already what I wanted to show about the general overview. So I prepared like a small setup. That's this here. And here we got first, we have it on the bottom, my power supply. It's a 5 and 12 volts power supply, meanwhile very cheap. But I only connected it to 5 volts here. And let me put me out the way. Then you got the coils here, the fuses here. I only put in like fuse for 5 volts. I didn't put in the high voltage fuses because inside the package I got there was this bag of fuses. So you get all the fuses with different values. So depending on what you want or which coils you put on your bank, you are already covered by the corresponding fuses. That's very nice. Also in my package I got this. I got all Molex collectors for the 156 mil headers. Those are the big ones basically. With all the crimps also. And to be honest, I've seen like a lot of Molex stuff, but this is basically the next system. Because those are really interesting. They got those basically those holder thingies here, which go onto the back of the header. So never seen those, but they are very similar to other Molex connectors I got. Okay, they're not Molex, JST-VH. Okay, so yeah, but they're nice connectors. I crimped a few earlier for that one here because my existing connectors didn't fit. But they work like any other crimp in your crimper. So they so far work really well. Then I got like a bag with all the small ones. So I guess those are like, I would say they call them Molex knockoffs, but they probably also got another name. Also with crimps, those are the normal well-known, which I also often use for basically instead of like the original Molex stuff. So those are also included. So it's really nice. So I got like anything included. Okay, KF 2510. Yeah, probably the name. But basically everything is included. Then I connected USB power. No, you cannot see it. I connected the boards via USB. And one of the nice things about this board is that it actually runs on USB power. So you connect the USB-C here to your PC and the CPU is up, switches are working. You do not need like an external power supply to have switches working. That's quite convenient. And that also gives you like the option to disable high voltage and still have like a running service mode. I mean, like the early Spike machines had the problem that if they disabled high voltage, then they would be unable to read the inputs on all the noteboards because the noteboards wouldn't be powered anymore. So that's something which you do not have here, which I personally like. And you also do not need any power for your CPU. That's great. There's like one thing which is a little bit tricky, and that's you have to make sure that your PC knows which CPU is which one, because via USB they look similar, very similar, and there are different ways to achieve that. Either you can program an ID to the CPU itself, or you can set like the port number, for example in Linux, and then map the name. But you have to make sure, because otherwise you connect them in a different order, or your boot order changes, then the serial port numbers will be mixed and the chains will be swapped basically. Because the way that MPF thinks of this board is actually it's two CPUs. Okay, you program the serial numbers. That's great. So yeah, if you got the pre-programmed board, then it's not an issue. But if you reprogram those, then make sure to put the serial number in. Otherwise, you will have like a random order. So like MPF thinks of this board as like two boards, right? And the one board is this one, the second one is this one. And then what's nice is that the actual input and output number is printed next to the connector, and the number is like, you can see it here, 1 and then 105 for example, right? That comes from like the OPP terminology. So 1 is the chain, so that's basically the CPU number, and then 0 is the first wing of the CPU. So traditionally there have been like multiple wings attached to the CPU, and that's basically how you one chain could be multiple boards, so that those boards could be chained. That's no longer possible in the newer CPUs, and therefore it's always 0 in Cobrapin, and then afterwards it's like the input or output number. But the nice thing is that it's actually reprinted, and you can just read the number here and program that exactly that way in MPF. So that's really, really nice. The same thing here for the inputs, which you probably cannot see because those large capacitors are shadowing the numbers. You might see it here a little bit, but there's my light isn't perfect enough for that. But just believe me that that's there. I already run my MPF machine here, and we can also look at the code. So for example, if I got 2 inputs connected here, and those are 008 and 009, right? And now what we can do, or what I already did, is we can configure those. And that's basically how this configuration looks. So first we set our hardware platform, as you typically do in MPF. You tell MPF that you're using the Open Pinball project for your machine, and that you use driver boards generation 2. I guess I'm not sure if it's even needed for OPP, but it has been an example, so I copied it. Then we got segment displays, and we will come to that in a minute. Let's just go over the system itself for now. And then you got an OPP section. That's where you generally configure your board, and there you give it the serial ports, which it should use, right? On Linux, what I'm using here, that's def, TTY, ACM0 and ACM1. That's kind of a name for a modem. And for that reason, on Linux, make sure that you stop any modem stuff in your system. So modem manager is something to stop on Ubuntu. Otherwise, that will mess with your Open Pinball project hardware. This one is probably no longer needed if Cobra already programmed basically the IDs. I manually mapped this. That's the other way to do it. So yeah, there are 2 ways to do this. So this is probably optional. And now we can configure switches. And switches basically are you configure with this syntax. So first the CPU, that's 0. That one is always 0. And then 1 for the first input. That's actually printed on the board. So I just took it and copied it here. And yeah, the same for the second switch, which is test switch test2, which is the second switch. Additionally, we got test 3, and that's a switch on the other CPU. So it's CPU 1 and 01, and that's also a switch which is in the front. So the switches I got are those here, where I got my connectors there, and the first ones here. So that's actually what I got here. Then I got coils, and yeah, as I told just a minute ago, that's 008 and 009. Just put the number here. It's the same syntax, right? CPU 108 would be the other output on the other CPU. And this matters, as I told you, for the CPU number matters, but only for hardware rules. So for pops, slings, and basically flipper fingers. For anything else, we currently do not use hardware rules in MPF. Theoretically, it would be possible for magnets and diverters, but we currently don't do that. And that's already how you configure that. Now let's skip this part for a minute and go to lights. Lights are like serial lights. There are also, so in Open Pinball project, there are also like traditional lights, so bulbs. But on this board, there aren't any traditional bulbs, so there are only serial LEDs. So you got 2 chains, 1 per CPU, and here the same syntax, CPU 1, that's always 0, and 0 is like the first LED in the chain. Then you can have any type, and you have to set subtype LED, otherwise it would be like a traditional bulb or GI. So they set this, and then it should work. Is it recommended to put Autofire coil switches on the same CPU? It's not only recommended, it's required. Otherwise MPF will complain. And that's also true for, also true for fast and for spike, and probably for some other systems. Fast has like this quirk that the first 8 switches are special, but for any other switch, that's also true for fast. It's generally a good idea, because if you keep like switches and coils to the same CPU, that will like reduce the latency for those rules, because it doesn't have to hit the bus, and there won't be any bus conflicts or something. And so that will be less jitter, more predictable, and in general better latency. So I would always try to do that if it's possible in any hardware platform. I actually connected all the stuff and we can look at that. So let's show the desktop here. And this is basically the MPF shell. Let's make it a little bit larger. Dial up the font. And I connected some switches here. And we can press them. You can see they work. What did you expect? And additionally, I did what I always do on hardware streams now. I defined coils and connected those to the switch inputs. So those coils here are connected to the 2 inputs via this board. And now I can pulse them, and you will see in the MPF console that one of the input becomes active because it's triggered by the coil. So here you can see those 2 events, they pulse. They pulse. So I pulse them via this event, and this then triggers the input. And that allows us to measure like the input latency of the system. Disclaimer, it will be a little bit worse on stream because the CPU is loaded, but we can run it anyway. And for that, we will go over here and we will run MPF hardware. So first we can run MPF hardware scan. That's something which is always a good idea. Didn't show that earlier, but you can see here that it actually knows really, really well what this board has. And you can also see the view of MPF on this board. So you can see that we got the Open Pinball project connected on 2 CPUs from MPF perspective. On this serial port, it's chain 0, has firmware 2.2, I think, 2.2.0. And then another one on chain 1 with the same firmware. And yeah, the other serial port. We do not have any incandescence. Yeah, that's fine. That's basically not physically available on the Cobrapin port. I mean, this is basically an opinionated Open Pinball project board. It has like certain wings built on this hardware, and that's like a great fit for most machines, for most single machines, not for dual machines like mine. So head-to-head machines, that's not enough of anything for a head-to-head machine. So you definitely need 2 of those for a head-to-head machine. But for a normal machine, that's something which will probably work for most machines. I mean, there are always exceptions to anything. And then you can see like the inputs here. So the chain 1 has those direct inputs, and those are then the matrix inputs here. As you can see, 64 inputs on the switch matrix. So mine is configured as a switch matrix. That's basically something you configure in firmware also. So there's like a small command line utility where you can tell the CPU what's connected. And you can still change that on Cobrapin and then have direct inputs instead of the matrix if you later decide that you do not like it. And on the first chain, yeah, you got those direct inputs here. Then we got the solenoids, one has 8 and the other one has 16s. And we got one chain of LEDs on each of those. You can also tell that the coil is firing when the yellow LED, with the yellow LED on the board. Ah, cool. So on the CPU, or which one? Ah, next to the coil. But therefore it probably needs power, I guess, right? Or does it work? Let me try. Let me run my MPF again. Oh yeah, it's firing. There you can see. That's nice. So here you can see it. That's also a nice addition. I like it. That's great because it's easier for debugging. So that's cool. Are there watchdog LEDs on the board to show power to switches, coils, etc.? Not sure if there's like a watchdog LED. No, I'm actually not sure. I mean, theoretically, those LEDs are controlled by the firmware. I'm pretty sure about that, and that's something which could be added in the firmware. I mean, if you ask you, then he will probably implement it in a few days. I guess, because like currently that's I think it's bus activity. So you can see now it's blinking because MPF is not running. And if I start MPF, then they will start. One of them are starting to flash. The other one is not. I have no idea why, but they both work. But maybe because one of them is updating the LEDs and the other one is not, probably. Or maybe one is reading the switch matrix. I don't know. But that's something which could certainly be added. That's the cool thing about open firmware. Even, I mean, theoretically, you can do it on your own. It's open firmware. You can compile it. It's just standard C. It's nothing fancy. It's just C. And even if you do not want to do it yourself, you can pay somebody to do it. That's also possible. And now we can run my hardware benchmark command. That's this one, hardware benchmark. And that will actually tell us how fast this hardware is. Again, disclaimer on stream, it will be a little bit worse. But this will now pulse the coil and activate the flipper rule, so that this first coil will activate the first switch. That will trigger the flipper rule. That will then pulse the second coil, and that will activate the second switch. And we measure how fast or how long it takes from pulsing the first coil until the first switch becomes active and the second switch becomes active. And with that, we now get like some data points here that's measured with like proper statistics, as good as I'm with statistics. And we can now look at it, and we can see here that the latency between pulsing a coil and MPF reading the switch back is like actually 7.79 milliseconds in average, with like some variance. In worst case is 15. that's pretty good, especially as the CPU is quite loaded at the moment. That's really, really good. Rule latency is around 1 millisecond, which is also like kind of expected. Minimum is near 0 and maximum is high. That might be like some CPU spikes. But in general, like 1 millisecond is like, that's expected because the hardware will actually sample like inputs, and therefore 1 millisecond variance is 1 millisecond latency is kind of expected. Rule latency is when a switch becomes active, how long does it take until the coil fires? That's actually the rule latency. So hardware rule latency. So you press the flipper button, how long will it take until the flipper coil will energize? Like the latency doesn't really matter so much as long as it's low enough. So you can have 10 milliseconds, that's not a problem, as long as like the variance and standard deviation is okay, right? So you shouldn't have jitter, because like a player gets used to anything between 1 and, I don't know, probably 30 milliseconds, maybe even 50. You simply get used to that, but you do not get used to like any jitter. That's bad. So that should be really, really low. So I recommend to run this on your hardware to see if you got jitter. And if you got jitter, you certainly got a problem. So, but as far all hardware we looked at on stream has been really good. And the same is also true for the Open Pinball project here. Yeah, then we look at how long so if we pulse the coil for 53 milliseconds here, how long do we measure the input? Is it longer or shorter? That basically lets us measure something on how does the CPU measure like the rising edge when the voltage increases and when it goes down. So that sometimes might be like a little bit asymmetric. So it might be off earlier than it goes on, right? And we see that on some hardware on OPP, it's actually pretty good, to be honest. I mean, this is actually on the point. So there's like, that's good. And the same on the rules. So, and we measure with different times, but the like results are very similar for all of them. Yeah, so that's pretty good. Even under load, that's great. Yeah, and I didn't expect anything else because that's what we already did with the Open Pinball project. So it's expected that this is the same on the Cobrapin board, but I wanted to verify because before I had the older CPUs, but they are not so much different. So that works great. USB is, that's in my opinion one of the systems with the lowest USB latency, which is good, which is really good. Other systems have a little bit more latency for various reasons. This timeout, that's probably because of CPU load, and then we hit a timeout here. That won't happen if you do not run the stream. Even if I just rerun it, it will probably go away. That's just something, if you see like 50 timeouts here, then it would be an issue. And this timeout usually is then, for example, the variance here. So you can see here it had one with 33 milliseconds, and that's probably where like we lost something on the CPU. So yeah, I added this otherwise it would like hang forever. And I think the timer was like half a second. If it didn't get it after half a second, then it basically lost the pulse. So it pulsed the coil, and either the pulse didn't happen, it would be bad, or the switch change wasn't recorded for some reason. That could also happen. And that's maybe what happened here. I don't know. But I've only seen this under load, never without load. But I also see that in other systems. So maybe it's also a problem in MPF. So basically what happens is that MPF pulses the hardware periodically, right? And if for some reason this period gets too long, then we might lose switch reads. And that shouldn't happen, but it still can happen under load. Some systems timestamp their switch changes. Like I think it's only the PROC system which does that. They timestamp their switch changes, and there it's very, very unlikely, and it generally doesn't happen. So that's the only system which is exempt from this problem, because they solve this reading switches stuff differently. Yeah, but like there are certain trade-offs in how you can build hardware. But in general, this works well for most systems, and it's also what Stern does, for example. So nothing wrong with that. The load is basically on my MPF computer here, because it's encoding the stream, and my PC is not that fast. It's an i5, I think 3rd generation, and the current generation is like 9th or 10th generation, so it's quite an old PC. Yeah, right. Cobra's right. So we've been talking about that. So that's really, and that's why I like the Open Pinball project, because they pick up on ideas, and basically, yeah, try to improve stuff even later on, right? So, I mean, it's not a huge problem, but that's the cool thing about open source. It can be made better, and then people will make it better. I mean, that's the same thing with MPF. Some stuff isn't broken, but it could be better, so we make it better. Do we have to? No. Does it make sense financially? No, never in the world. Is it fun? Yes, and that's the reason why we're doing it. I mean, you need your hobbies, right? And probably most of you got the same hobby as I have, and enjoy this kind of stuff, and that's the good thing. So it's important to keep the fun, otherwise it will get boring. Any thoughts on other expansion boards? More switches and coils. Maybe a board with 8 coils and 64 switches. Yeah, I mean, like, that's like an interesting point you're making, Dan, because you always have to think about like the ratio of coils to switches in controller boards, and then if you look at hardware, it's sometimes a little bit odd what they got, because what you want in a typical machine is like 16 to maybe 24 coils. So, right, that's the range. On like at least on modern Sterns, it's typically 12 to 16, but on homebrews or like even WPC, it's 16 to 24. And then you want like roughly 48 to 64 switches. And that's like a ratio of 1 to 3. So that's definitely what you want. So 8 coils, 24 switches, maybe even 8 coils, 32 switches. That would be ideal in my opinion. So then you can have like 2 boards, even 8 coils, 24 switches. Then you could have, then you would have 84 switches. That might be at the edge, but that would be like, you have 3 boards, then you have 24 coils. Yeah, that's good. That's a good ratio, I guess. So roughly that ratio. And yeah, like that's the cool thing about Open Pinball project. That's totally possible. And if you got those wings, then you can build it your own. But that's like, I mean, it's not so production ready, right? So with those wings, you probably have seen those. That's like below the playfield, it's like a little bit unstable. So those carrier boards like the Cobrapin, those are the better opinion in my opinion, the better option in my opinion. This board, I don't think it has servos. Also doesn't have stepper or anything. I mean, currently, that's what he's trying to say. Because I don't see why OPP couldn't support servos. I mean, the signal doesn't have to be very fast. It's like as fast as a normal PWM coil. So just trigger you and he might add it. So servo control is relatively easy. So might be possible. So I mean, yeah, that's the cool thing about open source. Really, I'm a big fan of open source stuff. Open hardware is a little bit new, but this is really like, in my opinion, a great project which is open source and open hardware and does it like really, really well without like any vendor lock-in or being like very crude. It's like, it's all well done. It's simple C code. It's compilable without like any special stuff. It's a mainstream CPU, and it's also like the switch CPU the first time now. So, and like the firmware stays the same, protocol stays the same. So from my perspective, it's good. It's really, really great. And I mean, in the beginning it had its problems, but most hardware platforms had their problems in the beginning. I mean, like commercial ones, they typically got better marketing. OPP is like very open about what problems exist and they fix them. That's not always the case for commercial vendors. Sometimes the bug, if this is minor enough, well, it will stay there for some of them, right? So that's what I really like about the project. So, and yeah, Cobra showed us what is possible if you now take this great firmware and just build like boards around it. And there's probably like a lot to explore. And in my opinion, like this board is already like pretty great. I mean, unless you want servos, that's a board which you can buy and build a machine with it. And like without fearing that you will like burn your house because it has fuses, it has like capacitors so that you won't run like into any voltage issues. My only critique would actually be like that, like the input protection is on the weaker side. So just be a little bit more careful. That I'm not sure if that would be something which would like cause issues in a production machine, but I would look for that a little bit. But even if that would cause problems, right, in doing playtesting or something, you could add like a few, like for example, a few resistors and a few diodes to basically protect this input at like it's a few cents plus the manufacturing cost. That would be something which you could add. And I guess like if you would produce this for a commercial machine, you might want to add this. But again, it's like it's a trade-off between space and costs and anything. And the CPU is cheap here. So this is definitely like a valid trade-off in my opinion. But I think commercial vendors might add this because like WPC had it and most commercial boards also have that. But besides that, it's great. I mean, like the transistors, the FETs are protected by the diodes. Coils are basically fused by bank. And since like the voltage is also fed to the board, this diode is also effective. So if you do not have high voltage on the board, then this is kind of tricky, this protection of the FET, because then like the voltage will go below basically through your power supply and back into the board, and that might be tricky. And that's well done here. Also, I like those covers over the fuses here. That's a nice touch, and also that you got like an LED here if voltage is on and so on. So it's a good package. And like the price, we do not have to talk about the price. It's really a great price tag. I don't know how much the final price will be like after the Kickstarter, but probably not 600 euros like most commercial systems. So the price tag is like a lot lower. and you get a lot of stuff for that. And that's definitely something which you can, oh, great. So below $200, I would say. So awesome. It's something which you can definitely use. Yeah, then like those displays, if you want segment displays, why not? You can have those. And you also get stickers. You do not need to be cautious about connecting legacy boards like Opto boards to drop boards because they can apply more than 3.3. Yeah. Yeah, right. So basically, like, this is a little bit different than normal, I would say normal, or most machines, or most hardware platforms do it. So typically, hardware platforms run their outputs here at 12 volts, and they like run a pull up at typically 1 kilo ohm to pull this up to 12 volts, and then your switch will connect this input to ground, and it will sense if this voltage drops below 6 volts. That's what they typically do. And that gives them like, the voltage is relatively high, so the resistance on all your switches does not really matter. And they also like run like buffer chips, which are relatively tolerant to, for example, negative voltages. So if for some reason something bad happens and you get like negative voltages, that won't like that won't like break your input. With those CPUs, they are relatively like, they don't like negative voltages. I guess like even 1 volt negative would probably fry the CPU. Same for like 5 volts, that would also fry the CPU. And for like the commercial boards, you can probably give them like 20 volts plus and 10 volts negative, at least temporarily, and they probably will survive. That's not the case here. So that's the only thing to keep in mind. Just be a little bit careful on the inputs. On the Cobrapin board, there are some like some solder connectors which you can make. So for example, for this high voltage relay here, you can basically put a solder dot there for to basically enable one of those relays permanently. So when this board turns on, it will enable the relay. So basically when it gets USB power. Or you can turn it to the output, for example. And I think there's one more, but I forgot what it was actually. Let's have a look. Here. For the matrix, for the switch matrix, you can have like additional like pull-up resistors if it's not strong enough. That's what you can also have. So like there are a few tweaks you can, small hardware tweaks which you can do on the bottom of the board. Like additionally, like there's a thermal, what's called basically an NTC. So it's like a thermal resistor, so it will prevent your board from, I think, Cobra will probably also tell that. I don't know what it does, but it's related to startup, I think, right? So it will prevent like the inrush current on the caps, or what does it do? But I think I read about this one. It's also there. It's there for some reason. So that's also there, and yeah, okay. So basically, it's like on the old WPCs where they got this small box in the cabinet to minimize inrush on your transformer, and this I guess this will basically minimize the inrush on your capacitors. Otherwise, that might shut down your power supply, especially if it's like a cheap one. So yeah, so like there's a lot of small things which hopefully improve your life a little bit and make your pinball machine a little bit better and less painful. I mean, we want to build great games, not fight like the hardware, right? And yeah, this hardware hopefully enables you to do that. Yeah. Do you have any other questions? Anything Cobra should explain or I should explain? Or I should guess and then Cobra explains it. So he built the hardware. I didn't. I just did parts of the MPF stuff, but he also did some improvements in the OPP stuff. And not to forget you, which did like a lot of work on the firmware for like this lamp matrix, for example. Here, he did some improvements for that. I think that hasn't been in OPP before. Also, like for the switch matrix, there have been some improvements. There are like matrices which are basically inverted, where you got an active high or an active low signal. That's mostly for older machines. For modern machines, you typically don't do that. But there's a lot of stuff. The relay output is to turn off high voltage. So what you can do with that is you can, for example, turn off high voltage until your PC is powered up and powered up the CPUs. That would be one of the use cases, and that might be to turn down any permanent stuff. So for example, I mean, nowadays you won't do that, but theoretically you could have GIs directly on high voltage, and then it would be always on. And you can have this relay to disable high voltage. Also, some machines disable high voltage during service mode. Sometimes you wouldn't do this in software. And that's what you can do with that. So then you can have like, you will have one output on your OPP board, and that will control your power. And that's actually what Stern Spike did for a while. They disabled high voltage in software. So if you opened the door, the software will read the switch and then decide, oh yeah, we will turn down high voltage. And that's what you can do here as well. And you can decide if you want to have 5 volts or high voltage or even any other voltage with that. And yeah, the dual relay output allows you to control both voltages with one output. That's how it works. Yeah, I mean, you can put anything on this relay. It's just a normal output. I think there's a small transistor on there to drive like 2 outputs with one. So you drive 2 pins with one output. That's basically the feature here. And I think you can also have, yeah, you can control anything with it. Doesn't have to be your voltage. Yeah, theoretically, yeah, I mean, you could use one of those outputs for your relay board as well. So you can also have like 10 relay boards here. That would also work. I mean, it would basically waste the FET because you're not using it. But in this case, you also have one FET which you're not using. So because like it's one output and it's connected to this and to one of the outputs here. And you will basically lose that output. Very good. Yeah, so it's a nice little addition, which some people say they want it, otherwise other people say they don't. And I mean, with like commercial power filter boards, they often got like an input for this. So you're supposed to connect a switch to an input. And a very common thing is to forget to connect this input or just bridge this, because then it won't turn on high voltage. And that's like, yeah, that's like something which happens on our forum every few months, I would say, where somebody just didn't enable high voltage because of that. So it's yeah, it's something if you have it and don't know it, then it's an issue. But here you can have it. Thanks. Yeah, that goes to Cobra mostly. I just presented today, and Cobra did the work on actually not only building this but also like producing a lot of those boards, and that's another kind of challenge with prototyping and so on. So you should not underestimate how much effort is to basically get this to like a state where you can produce it and actually sell it without fearing that you would basically burn up the house of other people. And that's something which takes a lot of iterations and testing and so on, and that already costs a lot of money. So that's really great that he did that. Yeah, you cannot have enough pinball control systems. I've probably got like 10 different ones now. And it will be more in the future, I'm pretty certain. Yeah, I got like one more which I will show you also like in a maybe next week or in 2 weeks. It's prepared, but I want to like finish a few things and make them really nice in MPF. And there's more coming, I think. And yeah, I mean, this one is definitely one of the cheapest ones I bought, and compared, it can do a lot of stuff. Yeah, I also got like 70-volt power supply in one of my machine. That's yeah, I wouldn't do that again. So, guys, thanks for joining. Thanks for chatting. Thanks for asking so many questions, Cobra. Thanks for explaining. Thanks for sending me all the stuff. I hope you all had fun. Hope you learned something. And I guess like if you already have the board or will have the board in the future, and all the rest will probably buy it, I guess. And yeah, so have a great evening, guys. Thank you. That's a cool emoji. And see you next time. Until then, play some pinball, build some pinball, have a great time. See you guys.